Okay, so I'm going to give you some notes covering section 11.2, which is titled Arithmetic Sequences and Series. It's kind of a breakdown of some things that we've been doing so far, like last week when we talked about some of those sequences, the patterns of numbers and whatnot. This is going to be broken into three different groups based on the three different things that you're going to be doing on your assignment. But for today, just kind of take some notes here, and then we'll be working with some of this information tomorrow. What I want to do is just take an example of something here. This is actually like an application here where you've got postage stamps that costs 23 cents per ounce. So for every ounce that you send in an envelope, it's going to cost an extra 23 cents. Down here, if you notice, here's what you could call a sequence where you have the first number is 0.37, then 0.60, then 0.83. So it's a list of numbers like what we had last week. If you notice, though, with each value, that each value is increasing by 0.23. So to get from here to here, that's adding 23 cents. Then you add another 23 cents. Then you add another 23 cents. That difference is what's known as the common difference, and we will be using the letter D to represent that value. So since this is going up by 0.23, then the D value here would be 0.23. If this were decreasing, then that D value would be a negative number. So I want to look at an example here. If you look at this sequence, the directions say determine whether it could be arithmetic. What it means to be arithmetic is simply just that you are either adding or subtracting a value to get the next term. So if you notice, this goes from -10 to -4. Well, if you add 6 to that, if you add 6 to -10, that gives you -4. If you add -4 plus 6, that gives you 2. 2 plus 6 is 8. 8 plus 6 is 14, and so on. So that common difference, the D value, would be 6. Okay, so I'm just using this as an example to kind of get into something that we're going to get into a little bit more specific. What we can do is, last week you had to find maybe the first, second, and third terms if you were given a formula. Like you were given a formula like A sub n equals, and then it would write some other stuff there. What we're going to do is take a sequence here and actually create that formula so that you can find any term in that sequence. And in order to do that, that follows, you're going to want to write this down. Write this formula down right here. This is A sub n equals A sub 1 plus n minus 1 times D. Now that D is the common difference. N is simply the number of the terms. That's going to remain a variable. And A sub 1 represents the very first term. So A sub 1 is the first term. D is the common difference. So here's how we're going to use that. If you notice, we're given a sequence, 20, 14, 8, 2, -4, and so on. We're asked to find the 12th term. Now, the 12th term is kind of far down the road, so rather than just continually subtracting or adding or whatever, what we can do is come up with that formula. In fact, you're going to be required to do this. So we're going to use that formula, that standard formula of A sub n equals A sub 1 plus n minus 1 times D. And I got that from that previous slide. Well, here's what we know. This 20, that is the first term. So that's A sub 1. So I can plug in 20 for A sub 1. As I said before, the n is going to remain a variable. We're just going to call that n minus 1 times D. Now, the D value, we have to figure it out. Okay, if you notice here, to get from 20 to 14, you would actually subtract 6, which is the same as adding a -6. To get from 14 to 8, you subtract 6. To get from 8 to 2, you subtract 6. So that D value is -6. We're going to substitute -6 into that equation. What that's going to do is allow us to distribute this -6 with that quantity. So really, I'm looking at an algebraic equation here where I have A sub n equals 20. If I take -6 times n, that's -6n. -6 times -1 is +6. So if I go ahead and combine like terms here, I would get, I'm going to write the n first, -6n plus 26. And that will be a formula for this arithmetic sequence. Now, what we were supposed to do is find the 12th term. Well, the 12th term, that's where the n value would be 12. So I'm going to find a sub 12, meaning I'm going to replace that n with a 12. All right, so I would get negative 6 times 72, which is negative 72. I'm sorry, negative 6 times 12, you get negative 72. I was looking ahead there. And then I'm going to add 26 to that. So that would give you negative 46. So the 12th term will be negative 46. If you want to check that, you could just keep subtracting 6 there until you get to the 12th term, in which case it will give you negative 46. I know that seems like it will be easier to do, maybe. However, you might be asked to find like the 85th term, in which case you're definitely going to want a formula like this right here. Let's try another one of those. And what you might want to try to do is actually pause this just to see if you can get this, and then play to see if you were correct. But to get from negative 3 to negative 5, and to get from 5 to negative 7 and so on, you actually subtract a 2. So what I'm going to do is use that formula, a sub n equals a sub 1 plus n minus 1. I'm still using that same formula, where a sub 1, what's the first value in that sequence? Right, it's negative 3. So I have negative 3 plus n minus 1 times d. Now this is your d value right here because that's what you're subtracting each time. Or if you're adding something, that would be a positive number, but we're subtracting here. So we have times negative 2. Okay, so I'm going to distribute that negative 2. So I have negative 2 times n is negative 2n. Negative 2 times negative 1 is positive 2. So if I combine the negative 3 and 2, that gives me negative 1. So I get a sub n equals negative 2n minus 1. I was asked to find the 11th term, so I'm going to find a sub 11 and use this formula that we just came up with. So I have negative 2 times 11 minus 1, which is negative 22 minus 1, or negative 23.